Hey there! My name is Earl Royce Hugo, and today I'm presenting my solution to our assignment in CMSC201. We were given two tasks. Number one is to prove an argument by resolution in first-order predicate logic, and number two, to simplify a set expression using set algebra. So let's start with the first task, which is to show a proof by resolution. I'm sharing the details of the actual problem in the description if you want to try it yourself. Note that in this presentation, I'll focus on the actual proof by resolution using the resolution tree. But before that, we need to convert all our statements into their conjunctive normal forms or CNF, and I'm showing them all here. For your reference, statement 8 is the negation of the original conclusion. Okay, so let's go to the proof. Personally, I usually start with the conclusion and look for a statement that has the same predicate but negated so that they cancel out. In this case, I found statement 3. I highlighted the similar expressions but noticed that statement 3 still has variables x and y, whereas statement 8 shows Ronald and pizza. So we are going to do a step called unification, basically to match the variables so that the argument lists of the predicates are the same. In this case, we have x equals Ronald and y equals pizza. Applying the resolution rule, we get the result as shown. By the way, for this entire proof, basically I'll repeat this step of looking for a matching statement and applying the resolution rule until it resolves to a contradiction. So for this, we have statement 1a to match the highlighted expression. That resolves to the statement here. We then use statement 6b to get a new statement and do it again with statement 7. Notice, however, that statement 7 again has variables, so we are doing another unification. For this, we have x equals Ronald, and combining these statements, we get Ronald is not hungry or Ronald is not at home. We choose statement 5 to match that and resolve as shown. We then match that result with statement 4b, which leads to the statement Ronald is not hungry. And lastly, we use statement 6b that states Ronald is hungry, which leads to a contradiction. Since we arrived at a contradiction, we can say that the argument was valid, meaning Ronald did eat the pizza represented by the expression shown. So we now go to task number 2, which is to simplify a given expression using set algebra. We were given this b minus a complement, intersection a, complement of that whole thing, minus a complement. When I simplify, I typically think through my general course of action before I proceed. So here right now, I'm thinking I will be using De Morgan's law to distribute the complement, and then I'll apply the definition of the difference. So as mentioned, my first step was to do De Morgan's law. I applied that to the big expression highlighted in red. I can see a double complement after b minus a, so I'll go simplify that next for step 2. And then I will apply the definition of set difference to b minus a, as well as to that other big difference expression involving the last complement of a. For step 3, I basically converted the minuses to the intersections with complements following the definition, which is a minus b equals a intersection b complement. Okay, so we have another double complement here. So a complement simplifies to just a. For step 5, I used commutativity to assist with the representation, followed by the usage of the distributive law to distribute the a intersection over the union. For step 7, I applied the inverse law on that statement in 6. The intersection of a with the complement of a is a null set. Step 8. Remember that the union with the null set is like the addition with 0. So by identity law, we just have the expression to the left of the union. For step 9, I used the commutative law to make the expressions align nicely in preparation for associativity at step 10 to group A with its complement, leading to step 11, where we have another inverse similar to step 7. And finally, step 12. Note that the intersection of any set with a null set is similar to the multiplication of any number by 0. So by identity law, we get a null set. Therefore, the given expression actually simplifies to the null set. Thank you for watching. I hope that was helpful. You can leave your feedback and questions in the comments section below. Have a good day.